Meet someone you'd like to be. National Talent Search Exam scholar from Doon School. Merit holder mechanical engineer from IIT Roorkee. Fellow and professor at Stanford University, California. And an accomplished music director. Meet someone who's passionate about physics. Meet Professor Charlene Sharma. Get your physics fundas clear. Not just gyan, marks par bhi dhyan. Because Charlene will tell you everything that books don't in Physics Today with Professor Charlene Sharma.
Lights! Hello, I'm Professor Charlene Sharma and I'm going to be your friend and guide to physics. Today we are going to study interference of light. Pay close attention to what I'm talking about and you'll get all the marks that you desire. Today we are going to study nature of light, electromagnetic spectrum, principle of superimposition of waves, coherent sources, interference of light, Young's double-slit experiment. And don't get worried, that's not too much. We're just going to do it off in a jiffy. In the course of figuring out the theory of relativity, Einstein sometimes used to say, it seems there is a supernatural higher power which doesn't want us to understand the true nature of light, whether it is a wave or it is a particle. Now, what do we mean exactly when we say it is a particle? A particle is like a tennis ball, a ping pong ball, a cricket ball. It's an object which you can throw. You can convert your potential energy into kinetic energy across the path which it traverses. A wave, on the other side, is pure energy. It's a disturbance. When a wave moves, particle does not move across that. Only the energy moves. Wave is energy and particle has mass. Let's not confuse the two. Newton, Max Planck, Heisenberg and others want us to believe that light is a particle. Whereas Michelson, Morley, Einstein and Maxwell want us to believe that light is a wave. Now, which one of them is true? Which one of them is correct? Very incredibly, both are. Sometimes it works to our advantage and it's easier for us if we suppose that light is a particle. Sometimes it is much simpler for us to suppose that light is a wave. This nature of light is called the dual nature of light. Now let's look at the electromagnetic spectrum that goes all the way from gamma rays to radio waves. A long range indeed, from 10 to the power minus 14 meters to 10 to the power 4 meters. Very narrow to very large. Somehow, visible light, light which we can see, lies in between, only in the range of around 400 nanometer on the violet side to 800 nanometer on the red side. That's a very minuscule part of this whole spectrum. From gamma rays to radio waves, the nature of the waves is exactly the same. Only one small part is visible to us. Now let's delve deeper into the wave nature, as interference of light can only be explained by wave nature of light. When I say wave, what comes to your mind? Perhaps ripples on a pond? But you might also remember another situation. A rope is fixed to one side and a man is standing holding the other end of it. He gives a flick on the rope. Something moves from the man to the other end of the rope. What is that? That is a bump on the rope. The man gives a flick, the bump keeps moving along the rope till the point it comes to a barrier. That bump is a wave. That bump is energy. That bump is moving in a direction which is perpendicular to the movement of the particles of the rope. Now, imagine the man keeps moving the rope up and down. This is what is called a harmonic motion. If the man's hand makes a harmonic motion, we develop a sinusoidal wave on the rope. This wave can easily be explained mathematically as a function of point x, displacement on that point called y, the time which it has taken to reach that point, and the speed which might be v. In our case, y is a function of t minus x by v. When we apply this to a sinusoidal wave, we can easily write this as y is equal to yn sine omega t minus x by v, where omega is the angular frequency of the wave. Now, when two such waves come together, we have to apply the principle of superimposition of waves on them, like in the figure here. Wave A is the same as wave E, but wave C is exactly out of phase with wave A. So when wave A and wave C come together, the net result is 0. But when wave A and E come together, then the net result is 2A or 2E, because both of them are the same. Essentially, what is happening is the concept of phase difference is very important. That can be mathematically put as delta L, which is the phase difference, is equal to n lambda, n being an integer, lambda being the wavelength. For it to be constructive, n needs to be an integer. For it to be destructive, it needs to be integer by 2. That means essentially when two waves are in phase, the crest and crest comes together. When they are out of phase, the crest and the trough comes together. Okay guys, let me introduce you to Aanchal. She's going to help me through the segments to come. Aanchal.
Hi, Professor Charlene.
Hi, Aanchal.
Hello, everyone. I'm Aanchal. Professor, my head is buzzing with loads of questions after so much gyan.
Oh, Aanchal, it's not just gyan. It's the mantra for success in exams. Okay, let's see how much they've understood.
So, should I start?
Oh yeah, I'm confident of my students. Okay, shoot. Take a wild guess. Intelligently.
Okay, so question number 1. Why do we conduct this experiment? What are its uses and applications?
To know the wavelength of light and to prove conclusively that light is a wave.
All right, and the last question now. What is the intensity of light at the center fringe?
As intensity is directly proportional to the square of the amplitude, we can show that if I dash is the individual intensity of both slits, then at the central bright fringe, I is equal to 4I dash.
Interesting, isn't it? Okay guys, I'm sure by now your fundas about interference of light are quite clear. See, this padhai shadhai is all fine, but we all know that the big issue in our lives is exams. You see, knowing a topic is one thing, but taking it on in your exams is quite another. After this short break, I'm going to be back with Professor Charlene's Exam K Fun Day. Don't go anywhere.